Hey guys, so today we're going to start looking at chapter number 9. So chapter 9 is titled, this big long word, Stoichiometry. Okay? So what stoichiometry is, and what the whole point of this chapter is we're going to begin to quantify the chemical reactions that we've looked at thus far. So in the last two chapters, we first looked at how to name and write the formula for different chemical equations. So for NaCl, we learned how to name it sodium chloride. Then if I gave you a name like magnesium sulfate, you learned how to write it MgSO4. So then in chapter 8, we looked at how to predict the products of chemical reactions. So you learned that if I gave you a hydrocarbon plus an oxygen, your products were CO2 plus H2O. We learned about synthesis, learned about decomposition, learned about single replacement, learned about double replacement. So if you don't remember and aren't familiar with those reaction types and how to predict the products, you want to go ahead and pause this video, go back, take a look at your one-page summary, and familiarize yourself again with those types of reactions. So in that chapter, we looked at not only predicting the products of reactions, but also deciding if a reaction even happens or not. For single replacement and double replacement reactions, we learned how to determine if you mix two chemicals together, if we're going to get a reaction or not. So we'll also still continue to apply that skill to this topic. So the whole point of this chapter is after we decide the products of a reaction, we look at the amounts of products produced and the amounts of reactants that are consumed. And so that is the whole point of stoichiometry. That's what stoichiometry is. So reaction stoichiometry is the study of amounts of materials consumed and produced in a chemical reaction. So in the previous chapter, a question might have been, you add sodium to a solution of silver nitrate, what are your products? But now the questions will become, you add 12 grams of sodium to a solution produced by adding 15 grams of silver nitrate to water. What are the products and what are the masses of the products produced? So we'll actually begin to look at how much of these products that we can make. So we won't quite get there in this video, but today we'll just begin to look at the basics of reaction stoichiometry. And so one thing to note before we get started, and I'll say this several times throughout the video, in stoichiometry and pretty much in chemistry moving forward, anything we do, equations must be balanced. So after you predict the products of an equation, it should be second nature to go ahead and balance the reaction. And then a lot of times you'll catch your mistakes in writing equations. If you write the equation and it's really difficult for you to balance it, that's a lot of times a good sign that you went wrong writing the equation somewhere. So if we look at the reaction below, C2H6 plus O2 yields CO2 plus H2O, and that should be an arrow. Sorry, it got printed odd. And we know that is a combustion reaction. We could have predicted the products and balanced it, but it's already done for us. So now we can think about how we would read that in words, what's really going on. So I could say now that 2 moles of C2H6 react with 7 moles of oxygen to produce 4 moles of CO2 and 6 moles of H2O. So if you think back to what a mole is, we know a mole is 6.022 times 10 to the 23rd of atoms, molecules, whatever it might be. So we could think of that reaction as being 2 molecules of C2H6 react with 7 molecules of oxygen to produce 4 molecules of carbon dioxide plus 6 molecules of H2O. But that's not super useful to us to think about it in those terms, because it's hard to conceptualize and isolate a single molecule or a pair of molecules. So it's also perfectly valid and perfectly true to think about it in terms of moles, because a mole of something is a large amount of something. It's many, many, many molecules. So we can measure that out in the lab and think about that when doing reactions. So for the sake of this chapter and chemistry moving forward, we'll think about reactions as a certain number of moles reacting to produce another number of moles. So now that we know that these numbers can be thought, the coefficients can be thought of as the number of moles that react, we can make ratios using those number of moles. And we'll call those mole ratios. So we'll write down a few things about mole ratios, and then we'll look at how to actually find them and what they mean. So a couple of things. Mole ratios are conversion factors. So just like we have conversion factors for distance, we could say that 12 inches is equal to 1 foot. I can also say that 2 moles of C2H6 produce 4 moles of CO2. So we can use those as conversion factors. So mole ratios are formed by using the reaction coefficients. So we take the coefficients from the balanced reaction in order to form mole ratios. And it's very important, so I'll say it again, equations must be what? They must be balanced. I cannot stress that enough to you that you must always balance your reactions. Okay, so then lastly, mole ratios will help predict amounts of products and reactants from a balanced equation. So those are some basic facts. But now let's jump down and look at how we actually form mole ratios. So if you look at the next example, we have nitrogen gas plus hydrogen gas produces NH3 ammonia gas. So hopefully at this point in chemistry you recognize something's wrong here. Something has not yet been done. Hopefully you see that reaction has not yet been balanced. Let's go ahead and do that. We can do that by putting a 2 in front of NH3. We can put a 3 in front of H2. And we don't put a number in front of N2. We just leave it there. But we could put a 1 because the 1 is understood, but it's not necessary to do that. So now we have 2 nitrogens on each side and 6 hydrogens on each side. So make sure that you get in the habit of anytime you see an equation, go ahead and use your coefficients and balance. So now what I want to do is find the ratio of amounts between the different products and reactants. So based on this balanced equation, I could read it and I can say 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of NH3. That's probably worth going ahead and writing out. So you can write 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of NH3. So if I want to break that down piece by piece and form ratios from it, I can say 1 mole of nitrogen reacts with 3 moles of hydrogen. So a mole ratio could be, we'll just say 1 mole N2 to 3 moles. So in previous math classes, you're probably familiar with writing ratios like that. But for the sake of chemistry, we don't want to do that. We want to write it like this. We want to write 1 mole of nitrogen reacts with 3 moles of hydrogen. So that is a ratio that we can gain from that formula. And we could also write the opposite of that. We could say that 3 moles of hydrogen react with 1 mole of nitrogen. And we'll learn in the future the different situations and when we might want to flip that. But for now, let's just worry about writing all the possible mole ratios we can gather from this. So we can also look at the ratio that exists between nitrogen and NH3. So I can say 1 mole of N2 produces 2 moles of NH3. And I can say the opposite. 2 moles of NH3 is produced from 1 mole of N2. And then lastly, I can look at the ratio that exists between hydrogen and ammonia. I can say 3 moles of H2 produces 2 moles in H3. And then I can say 2 moles in H3 is produced by 3 moles of H2. So if you include the phase symbols here, it's not incorrect, it's just not necessary here. So these are all the possible mole ratios that I can gather from this little small equation here. So that's quite a bit of information that we can get here. So hopefully now you can begin to see why reaction stoichiometry is important and why it exists. We can't just say that 1 gram of nitrogen would produce 1 gram of ammonia, because if we see that 1 mole of nitrogen is able to produce 2 moles of ammonia. So that's why we have to learn the new process for doing these calculations. So let's look down at the next example. It says write all the possible mole ratios for the following equation. So I have aluminum reacts with sulfuric acid to produce aluminum sulfate plus hydrogen gas. So first let's ask ourselves, what type of reaction is this? Just as a refresher. Hopefully you recognize that this is a single replacement reaction. Hopefully you could also write this in words. Or if I had given you this in words, hopefully you could have converted it to symbols. So go ahead, pause the video, take a few minutes, and try and write all the possible mole ratios that can be produced from this equation. But before you do that, hopefully you recognize there is one other step that must come first. First you must balance the equation. So let's think about how I can do that. So I have 3 sulfates over here, 1 over here, so I can put a 3 out in front. Then I have 2 aluminums here, I only have 1 over here, I can put a 2 there. Now I have 6 hydrogens here, so I can put a 3 there. So now I have 2 aluminums, 6 hydrogens, 3 sulfates, 3 sulfates. Okay, so now you're good to go. So go ahead, pause the video, take a second, write all the possible mole ratios, then you can restart the video and I will show you the answer. Okay, so hopefully you were able to get quite a few answers for this, so we can now go through them together. So I can say that 2 moles of aluminum reacts with 3 moles of sulfuric acid. And so just for the sake of space, I'm not going to rewrite it, but another possible answer is that you have the exact opposite of this. So you say that 3 moles of sulfuric acid react with 2 moles of aluminum. So you should have both of those answers there. So then I can look at aluminum and aluminum sulfate. I can say 2 moles of aluminum produce 1 mole of aluminum sulfate. And then hopefully you also got the exact opposite of that. You got 1 mole of aluminum. 1 mole of aluminum sulfate is produced from 2 moles of aluminum. So then I can look at sulfuric acid and aluminum sulfate. So I can say H2SO4, and I have 3 moles of that with aluminum sulfate. So 1 mole, Al2SO4, 3. And I would also have the exact opposite of that. I can look at aluminum and hydrogen. So I can say 2 aluminums, or I should say 2 moles of aluminum. This says mole. I tried to convert my A to an M there. So 2 moles of aluminum can produce 3 moles of hydrogen gas. Then I could have the exact opposite of that. So then I can look at sulfuric acid and hydrogen. So I can say 3 moles of H2SO4 produce 3 moles of H2. You could also have the exact opposite of that, and you probably see now that you could reduce that. So instead of 3 and 3, if you wanted to say 1 and 1, that would also be perfectly okay there. And there's one more that I'm missing. Here we go, aluminum sulfate versus hydrogen. So I can say if 1 mole of aluminum sulfate were produced, then I would also produce 3 moles of H2. So let me go back and check myself. I have 2 aluminums, 3 H2SO4s. I have 2 aluminums, 1 aluminum sulfate. I have 3 sulfuric acids, 1 Al2SO4, 3. I have 2 aluminums, 3 hydrogens. I have 1 sulfuric acid and 1 hydrogen because I reduced the 3's down. Then I have 1 aluminum sulfate and 3 hydrogen. So those are the 1, 2, 3, 4, 5, 6, 12 mole ratios that we can produce from that equation. So as you could probably guess, it's not super useful to us just to list out all the possible mole ratios. That's not an exercise that we'll undergo very often. What we'll do is we'll learn moving forward how to just select the mole ratio that we need. But before we can select the mole ratio that we need, we have to know how to produce all the possible mole ratios. So now that we have this information, we can move forward and actually start doing calculations and actually do some reaction stoichiometry. So there's a note at the bottom of your page. It says reaction stoichiometry deals with mass or quantity relationships and reactants and products. So if we remember, the unit that we typically use for mass is grams. We can measure out grams in lab. I can give you a balance. You can scoop it out and measure, and that's great. However, we know that moles measure amount. Okay, so moles help measure the number of atoms that we have. So if we think back to this example, I can't say that 2 grams of aluminum produce 3 grams of hydrogen. That's not a true statement. However, I can say that 2 atoms of aluminum produce 3 molecules of hydrogen. That is the comparison that we need. We need to compare moles to moles. And when we convert from reactants to products, we have to consider the number of moles, not the number of grams. However, because we actually do real chemistry in lab, and in the future you will, you need to know how to determine the number of grams that react, or the number of grams that are produced, because these are quantities that we measure. So what we'll do in the coming videos and coming days is think about how we can go from a balanced equation to an actual number of grams that can be measured.